Good morning. I'm going over Unit 10, Lesson 8. This guided practice is only about 6 problems, and essentially it's going to be a quick um, lesson. It's once you look at the problems and see these examples, you'll realize that it's not a too complicated of a process. So let's begin. Lesson 8 starts with problem 1, 2, and 3 of the guided practice, and this asks us if there's line symmetry. So we're supposed to say yes or no, and then how many of line symmetry. And then problem 5 and 6 has to do with rotational symmetry, which I'll go over, and then problem 8 has to do with plane symmetry or axis symmetry. So line symmetry means essentially I can explain it to you. The definition of from the book is from page 930, and it says a figure in the plane has line symmetry or reflection symmetry if the figure can be mapped onto itself by a reflection in a line. So essentially, this is like a diamond, and it wants to know if there's line symmetry, meaning if I was to draw a line through the object, could I map the other half onto it, or does it create a like a mirror image? And so yes, this shape has line symmetry, and it has four lines, and I'll show you right now. So if I drew a line right here, these two images are the same if we cut it in half. Likewise, if I drew another line through there, those left and right side are um, basically mirror images. And then also we can draw a line going like this, and it creates two halves that are equal right here, right here. And then lastly, we can do the same thing from the other side where we have two halves that are equal. So basically, that's what a line of symmetry means, is if we draw it a line through the shape, do we have two equal sides that are like a reflection of one another? So for this example, number 1, it's yes, and how many is 4. I know that this looks like it could be a line of symmetry through here. However, um, that is not the case. This is a scalene triangle where all sides are different in length. So this would be no. Even though my drawing shows that it could possibly be one, it's not, because this length is different than this length and that length. And if you have a triangle that's a scalene triangle with all different side lengths, you're not going to have any lines of symmetry. And lastly, we have this trapezoid. And even though it's not drawn like the book, technically we do have one line of symmetry, meaning if I was to um, draw a line directly down the middle like this, these two sides of the shape are reflections of one another or equal to each other. So number 3 is yes, and there's one line of symmetry, and the book wanted you to draw it. So on the independent practice, it's going to want you to draw the lines of symmetry on the shape. All right, now we're getting into a different concept. This is from page 931. It's called rotational symmetry. So we have different types of rotational symmetry, meaning we have a center of rotation always in the center of the shape, and it wants to know if we spin this, basically this shape, it's a rectangle, counterclockwise, so it's always counterclockwise in that direction. Can we rotate it to where the shape will like land on itself or look identical to where we started? So if we did 90-degree angles, the rectangle would be like this. Does that look like the original shape? Granted, it is the original rectangle, but when we spin it 90-degree angle to the left or counterclockwise, it does not line up. Well, what if we spin it again 90-degree angle? Then we would get the rectangle in its place, just like the original. So if we were to take this and spin it 180 degrees, we would get a shape of the rectangle to make it like look like the original or land on itself. So essentially, yes, there is a rotational symmetry and it wants you to label it. So it's 180 degrees. All right. So now we're looking at the next problem, problem 6. Problem 6 has like a windmill looking object. And these, even though the drawing doesn't show it, it wants to know that I want to tell you that it's all equal. All of um, these little triangles that are connected to the center are equal to each other and they're spaced out equally. So again, if we were to rotate this counterclockwise and spin it at the origin right here, there is rotational symmetry. And if we go 90 degrees and just shift it over, we are going to have it land on itself. So basically, if you look, this is 90 degrees away from each other, 180, and then like basically 270, and then 360 would rotate it onto itself. So you can also think about it like this. If we have, say we had an axis, right here would be a 90-degree angle, right? So if you look and pretend there's an axis drawn through it and we rotate it on this axis, that's already going to be a 90-degree angle right here. If we drew that shape and then drew that shape like that and so on. That would be 90-degree angles. So it's a 90-degree angle rotation for number 6. All right, lastly, this is from page 932. It wants to know if it has this cube right here. I drew a cube. It's a three-dimensional cube. If it has plane symmetry or axis symmetry. So if you go to page 932, you can see an example. So plane symmetry, by definition, says a three-dimensional figure has plane symmetry if the figure can be mapped onto itself by a reflection in a plane. And then axis symmetry says a three-dimensional figure has axis symmetry if the figure can be mapped onto itself by rotating between 0 and 360 degrees. So say we had a center of rotation in the center of the cube and we were to rotate it any way. This is a cube that's equal on all sides. So I believe that's what the book had. Let me just double check. It's not equal. I guess the front faces and the back faces are taller than the sides. However, it doesn't matter because by definition, if we rotate the cube in any way 0 to 360 degrees and it basically maps onto itself, then it would have axis symmetry. So if we take this cube and rotate it 180 degrees, it's going to look like that. And if we rotate it again another 180 degrees or 360, it will map back onto itself. So it does have axis symmetry. Plane symmetry means if I drew a plane, a three-dimensional plane, it's going to be hard to draw. But essentially, remember, a plane is like I'm just going to shade it. So say I drew like a plane through here. It's like a rectangle that separates this. Are we going to have two sides or two parts of the cube that are equal? So pretend I had a cube and I put a card, like a playing card, right between this. Is it going to create two equal parts? And yes, so if I took a plane this direction, it's going to have a top part of the cube and the bottom part of the cube, or the rectangular prism, and it's going to show that it's two equal parts. And then the same thing up here. If I was to just draw a plane vertically through the rectangular prism, it would create two equal sides. So it also has plane symmetry. So the solution would be it has both plane symmetry and axis symmetry. So that is problem 6. So that's pretty much lesson 8. It's a fairly straightforward lesson. I am going to post this onto YouTube right now, and I will also do Unit 10, Lesson 9 today, and or by tomorrow, and also the unit review as well. So we should be done with the lessons by tomorrow or later today, and their unit review in the next couple days. Anyways, have a great day.